Báyìí, nǹkan tá a fẹ́ gbé ẹ̀wọ̀ náà ni dimensions of physical quantities. Dimensions of physical quantities. A ti sọ nípa fundamental quantities, a sọ nípa derived quantities. A tún dẹ̀ wo fundamental units, a tún wo derived units also. But for now, a fẹ́ wo dimensions àwọn physical quantities yẹn tí a yẹ̀ wò. Ẹ má gbàgbé mo sọ fún yín pé we have two categories of physical quantities. Mo ní a ní fundamental quantities and what? And derived quantities. Now, so what are derived? What are the dimensions of physical quantities? It is the way they are related, connected, or associated to fundamental quantities. Fundamental quantities. So, nǹkan tó so wọ́n papọ̀ bí wọ́n ṣe wà interconnected on la fẹ́ wò nísinsìnyí. So, àpẹẹrẹ ta níbí báyìí ọ̀nà pè ní only length wa again. Don't forget we are referring to fundamental quantities, how they are related. A sọ nípa unit o, a sọ nípa unit. So, we have L, for example. The first one we have what? Length. This time around, we're not dealing with units, we're not dealing with meter, we're dealing with the dimensions. So the first one we're going to work with here is length, and then this one is what? L. Capital L. It's noted with the letter L. Now, the second one we have what? Is mass. It is not kg. Won't say kg, won't say kilogram. This one is what? Capital M. Because we're talking about the dimensions now. So, look at that, is what? Is time. This one is what? Capital T. Atuni electric charge. This one is what? Capital A. Atuni temperature. On the capital K. So, ó kàn sọ fún wa bí wọ́n ṣe wà connected, their connections with themselves. Wọ́n ṣe wà nǹkan tó so wọ́n papọ̀ ká fi máa ń lò nínú calculations wa. So, akẹ́kọ̀ọ́ wo àpẹẹrẹ kan kọ́ fún wa, òun náà ní kíni, òun náà ní speed. Wọ́n ní ká wá dimension speed. Wọ́n la fẹ́ gbé yẹ̀wò. Don't forget that we're not dealing with units. We're dealing with dimensions now. So, now, for speed now, I'm okay. Formula for speed. I'm going to distance over time. Distance covered over time taken. Now, we're talking about distance. We're talking about the length, right? The length covered. Okay. And then the distance is what? Is length. And that is what? L. Capital L. Is noted as what? Capital L. As ma time wa, kini time wa, mo iso ni by, we on the capital T. Show you what? Now, we're going to proceed with this. We're going to have L T raised by raised by minus 1. L T raised by minus 1. So, electric ta fẹ́ wò, ọ̀nà ni kíni velocity. Kíni mo pè velocity. So, we have this one to be what? Displacement over time taken also. Okay? So, and then this one is similar to that of speed. And then we have L over T. Other one, L T raised by minus 1. L T raised by what? Minus 1. After wo acceleration, linear acceleration. Linear acceleration. 3. Linear acceleration. So, and now, formula for this one is what? It's velocity over time, right? Velocity over time taken. So, now, as in getting velocity to right? Abi, our connection on what were interconnected. Now, so velocity is what? L to raised power minus 1. So, and then our time is what? Our time is noted as what? As t. So we have L t raised power minus 1, and then we have what? We have t. So mathematically, if you are solving using the law of indices, we have L t raised power minus 1 times what? 1 over t. I'm not simplifying this equation, right? So multiply later into alpha then by Abi. So then we have L t raised power minus 1 then times t raised power minus 1. Minus 1. From the law of indices, we have this to be what? Whenever we have something like, whenever we are multiplying, we're going to do what? We're going to add. Now, so we have LT minus 1 plus 1. And I'm more because we are simplifying it. So we're going to pick one of them because they are the same. We're going to pick one. And then this one is going to come here. This power minus 1. If we are multiplying, we're going to add from indices, right? So we have LT minus 1 plus the minus is what? Is minus 1. After making your LT raised power minus 2. LT raised power minus 2. What's the funny? I'm wrong. Don't you like anything my machine? Or not the kineo, or not the force. Not force. And the formula for force is what? Mass times acceleration. Mass times acceleration. Mass times acceleration. Now, kini mo pe mass fún alẹ́ kan yẹn, mo pe fún ní m, àbí capital M. Multiplied by acceleration, that's get to be by half one kini o L t raised power minus 2. L t raised power minus 2. Àròpọ̀ ẹ̀, àbí tá bá multiply ẹ̀, half one kini, half one n L t raised power kini o minus 2. So, àti rí ti first báyẹn. Ẹlẹ́karùn-ún, tá fẹ́ gbéyẹ̀wò, ọ̀nà ní kíni o, ọ̀nà ní à ń pè ní work. Àwọn fọ́múlà yìí, àwọn gbọ́dọ̀ mọ̀ wọ́n sórí lékè wọn fún wa tó bá ń ṣe calculation wa. Àgbọ́dọ̀ ṣe kíni, àgbọ́dọ̀ mọ̀ wọ́n sórí. So, we have work now. Tó jẹ́ ẹlẹ́karùn-ún, tá fẹ́ gbéyẹ̀wò, work. And our work is given as what? Force times distance. Force times distance. So now, kí ni force wá fún wa? Àti ṣẹlẹ̀ kan, ó fún wa ní kí ni o? MLT raised power minus 2. MLT raised power kí ni o? Minus 2 times the distance wa. Remember, we are talking about the distance. So distance wa dẹ̀ fún wa ní kí ni o? L is noted as what? As L. Now we're going to follow the law of indices again. Add fún wa ní kí ni o? M L. Now, if you are multiplying, you have to make sure that you are multiplying similar numbers. Okay, you're dealing with similar numbers. When you pay eléyìí, akọ dúró síbẹ̀. As a kini, we are going to multiply similar numbers together. Add ṣe kini o? After ní L. L times M after ní kini o? After ní L raised power 2. Abi. Then we have T raised power minus 2. As simple as ABC. Now, a ti fẹ́ wo òmíràn, a fẹ́ wo power. Power. So, how am I finding kí ni o? Formula for power is work done over time taken. Now, work done over finding kí ni o? Àti get to work by. So I find M L squared t raised power minus 2 over T. Following the law of indices again, after my calculation, I have to find M L squared t raised power minus 2 times 1 over T times 1 over T. On further simplification, I find M L square T minus 2. Now, about minus 2, okay, times T raised power minus 1. Okay, I repeat, me by because simplify 1 over T, what the find T raised power minus 1. So, and they got to move so most of our life, if you are dealing with something like this, your T, you go and meet T. Abi, T my bad T. So, after M, L, after MLT square, T. In this is again, if they are multiplying, they're going to do what? They're going to add together. So, minus 2 plus minus 1. Because we are following the law of what? Of indices. Because they have similar alphabets, right? So, then we have this to be what? ML square. Then we have T minus 2 plus and also give us what? Minus 1. Now, the about test value alpha kini M L raised power 2 T raised power minus 3. And we have to get to the T power by. They got some more me. And they got more pressure. And they got more pressure. Pressure, my formula for pressure is what? That's number 7. Pressure is what? Force over area. Force over area. Kini force over formula how did they run T? So force over formula ML T raised power minus 2 over our area is what? L square, right? So L square. Or further simplification, I'll pay M L T raised power minus 2. I pay L raised power 2. Let me buy. We'll say pay L times L. L will cancel L here. After coming by, I'll find M C raised power minus 2 times 1 over L. Abi 1 over L times 1 over L. So if we proceed further, I'm finding M T raised power minus 2 times L raised power minus 1. Now we don't leave our answers like this. We have to follow alphabetical order. That's been alphabetical order. So L masaju T by other finding M L raised power minus 1 T raised power minus 2. I pay at a read the pressure no buying. You can test what you got here to mirror. Let's look at momentum. That's number 8. Momentum is what? All this of what? Mass times velocity. Mass times velocity. Now, and then our mass is what? Is M, capital M, right? And then our velocity is what? L raised power L times L T raised power minus 1. This is that simple. And finding M L T raised power minus 1. Very simple. And I got to what mean? And I got what? Impulse. The formula for impulse is number 9. Impulse is force times time. So, and then earlier, our force gave us what? M L T raised power minus 2 times times time. Thank you. So, other one M L T raised power minus 2. Law of indices, if you're multiplying, you do what? You add plus 1. I'm finding M L T raised power minus 1. Negative concept. So it will cut away, Negative concept. That makes number 10. ká wo density. Density máa fún wa ní kí ni o, mass over volume. Now, our mass is what? Is M, right? And our volume is what? LQ. And the final thing you M raised to power 3. Àti bẹ́ẹ̀ lọ. So, mo ti ṣe example bí mẹ́wàá fún wa. So, mo fẹ́ kí a gbé yẹ̀wò ká tún wò dáadáa. Ká tún lọ wo àwọn example mìíràn sí. So, ní báyìí, a ti parí kíláàsì wa títí òní. Ẹ ṣé púpọ̀.